Hi everyone, and thank you for joining me today. My name is 𝗶𝗶𝗃. I'm a senior application scientist here at the Zeiss Microscopy Customer Center in Dublin, California, and I'm happy to be part of your digital engagement team. Even when we can't be beside you at your microscope, we are here for you in the Microscopy Customer Center. Really excited to be talking to you guys today about something we call direct processing. And for those of you who aren't familiar with it, it is something that is really wonderful to be built into our software so you don't have to do these additional post-processing steps after your experiment. They can be built into your experiment so that your data is really ready for you to analyze or put into your lab notebook when you're done. So just an example here, this is a three-dimensional time-lapse data set, right? Normally, once you're done acquiring this on the instrument, then you have to go into the processing tab or potentially take it to whatever analysis software you use and do your post-processing steps there. Your post-processing steps might include things like deconvolution or turning your 3D volume into a max intensity projection so that you can watch your time lapse more easily in one dimension and see what's going on. Stitching your basic Widefield images. Most of us who are doing microscopy are not exempt from having to do post-processing steps, right? And so this can become really cumbersome feeling sometimes when you are doing things like, let's say you have a 96 well plate and now you've got all of these tiled images or Z-stacks and you have to, after acquisition is done, now you have to go in and stitch these together or post-process these together. And we actually have some really cool stuff built into ZEN already that's been there forever. Since before I even worked at Zeiss, when I was just a customer, like batch processing. But for some of the more advanced applications, it's really, really nice to be able to actually tack that into your experiment now and not have to do it as an additional post-processing step. So, the idea being that you can get to your results quicker. You don't have to take that extra time. You just stick it in your experiment in ZEN, and it will do that after it's done acquiring the image. It's really, really powerful with time-lapse images. So as soon as that one time point is done, it'll start processing so that virtually as soon as your experiment is over the next morning, your data is also done being processed. So it's really, really wonderful. You can get to your results more quickly with direct processing. And it doesn't just apply, like I said, to more advanced applications. I'll be talking about a few of these today, but we've really in the last couple of years started to apply this across the whole light microscope portfolio. So, it doesn't matter if you are doing advanced applications like lattice light sheet or using an Airyscan detector on your confocal, or you're doing structured illumination microscopy, so SIM or apotome. It is really, really wonderful in those because, right, as a part of that light microscopy application, you have to do a post-processing step. But even if you're on a basic Widefield setup, you can use it for things like stitching tiles, right? As soon as you're done, especially once you start doing more than just one position at a time, it's wonderful to be able to set up this multi-position experiment and have it stitch as soon as it's done. Again, so you don't have to go in and click in that processing tab in ZEN like we normally would here, right? We have a processing tab, we go in, we find our function, we apply it. Potentially you could do a batch version of this, but having it actually done as soon as you are done with the acquisition, like you don't have to be in the room, it will take care of it for you. And I'll talk a little bit as well about how we can do it with Z-stacks and basically turning those into max intensity projections or spectral unmixing even. We had a really, really nice micro-minute the other week talking about spectral unmixing, and a reason why that's important is because you don't want to throw away any light, right? And so a lot of times we have to deal with fluorescence bleed through by cutting off a lot of the light that we are emitting from our sample. Well, if you want to image more gently, then you don't want to cut out any of that light. And so we can capture all that light and unmix it on the fly, build that into your experiment. So it's really, really powerful as a tool, direct processing, which is what we call it here. And the way that it works is we actually set up, now you can actually do it on the same instrument that you're acquiring on. But initially it used to be something that you would have to port over to an offline PC. There's multiple ways to do it now, and I'll talk a little bit more about the different software versions in a second. But first I think we should look at what does this actually look like, right? We're going to start our experiment in ZEN and we're going to have it set up in our experiment setup to then do that whatever post-processing step we need, stitching, max intensity projection, Airyscan processing. You pick your favorite, you pick what you need for your experiment, and we're going to have it start doing that on the fly once it's done acquiring the image. So for example, Here we're on, in this first example, a Widefield microscope. I went in and selected direct processing in the software, which don't worry, I will show that a few times if you missed it this first round. But what's really nice about this, we're just going to do some basic tiling here. And what you can see is when I selected direct processing in this drop-down window that's come down, we have all the same functionality that you would see if you were doing this after your experiment in the processing tab, right? You can still pick, in this example, whichever channel you want to use as your reference channel for stitching. You can pick how much your overlap needs to be if you did change it from the default settings. You pick if you fuse the tiles or not, right? All the things that you expect to have as your little knobs that you can control in your post-processing steps, they come into your experiment setup so that when it's done collecting that image, it starts doing this here, and you don't have to, again, do it later. You don't have to wait for your data to be acquired for it to start doing this. So in this case, we're just taking a basic Widefield tile. I'm going to actually process it on this PC. I believe in ZEN versions 3.7 and above, you can actually do it on the same PC. You don't have to actually be set up to an offline processing workstation. It is helpful, though, again, you have to be mindful of your RAM and your GPU and all of that stuff when you're thinking about what kind of processing you're doing, but you can actually do it on the same instrument now. It's really powerful. So what we're going to do is I have just used our AI sample finder to take an overview image of this mouse kidney, and I've just drawn, you can see in yellow here, a little section that we want to tile, and I don't want to have to stitch it after it's done. I want it to do it so I can look at it immediately, right? Something else that I have set up here, you have a couple of different options in direct processing where if you are wanting to compare these left and right, you can set it up to actually show you in a multi-window view side by side your process results compared to your raw data. So that's what I set up here. You can also set it up to just pop up in a new window or not open at all. You just want to save it into that folder, whatever floats your boat, you pick. And so you can see here, right, we're capturing this, just a basic Widefield image, 2-color. And once it's done tiling, we will see in a couple seconds after the stitched image pop up in the right because we already set that up and we built it into our workflow. So you don't have to take any additional steps once you start your experiment. It'll process for a second and boom. Now we can see side by side. There's even a little notification that popped up that'll let you know direct processing was done. And this is really nice because in this split panel view, we can actually zoom in and just double check that we like how the stitching looks. Did it actually fuse the tiles appropriately? Are we happy with the settings, etc. Another really nice thing to point out is that you are saving the raw data and the process data, so it's not like we're throwing away the raw data, right? You have it there if you want to tweak anything later, if you need to come back to it. But next I want to go into Airyscan, and so what I'm going to show you next is, this is a 32-channel detector for those of you who aren't familiar. And the reason why that's important is because we always have to process that raw data that comes from these 32 individual detectors before we can do any analysis with it or more easily visualize our final experiment. So what we're going to look at are some cells that are expressing Rab4, an endosome marker with emerald, so in green. And I'm actually using a mode that we call multiplexing, where you can scan 8 lines at a time, right? Normally on a point scanner system, a confocal system, you're scanning 1 point at a time. Here we're scanning 8 points at a time. You have to post-process that raw data to look at the final result. It makes us able to image really dynamic live cell processes, but we have to add that post-processing step. So it's really nice when you build it into your experiment, which I'll do here. I'll have the Airyscan processing function added, and then you can also build out now additional functionality on top of that. I want to do my Airyscan processing, but in this case, because I'm also taking a time-lapsed Z-stack, at the end of this, I want to see what that max intensity projection looks like immediately so that I can see if I, captured my endosomes transporting whatever molecule of interest potentially, as an example. Here we're just looking at 1 color. But, right, you want to see that like as soon as it's done. I know how all of the scientists are. I used to, be a staff scientist in a lab before coming here to play with all of your samples. And so this way we can build in and add an extended depth of focus. In this example, so we do the Airyscan processing, extended depth of focus. Now we're going to see our result virtually as soon as it's done collecting this time series Z stack. And I set this up just to go as fast as possible, so this is a very fast acquisition. We're just going to do 10 time points. This one I just set up on the remote PC. You can see what that looks like in the direct processing selection. But from there, all you really have to do is, start your experiment, and this is really wonderful, like I said, when you're doing like an overnight time lapse, it will basically be ready for you when it's done, because it starts each time point as soon as it's done collecting. So here we're going to very quickly take this 10 interval time series with, I think, 10 stacks each, just to show you guys, kind of what it looks like. And then if you want to see the progress that it's making, right, because this is a very rapid acquisition, it's done in a couple of seconds. And so we can go up and see on the acquisition PC the progress. You see this little blue bar over here. It's showing me how far it's processed on that offline workstation in this case. And then once it's done, it'll pop up the new data set and the software, but I didn't have to really do anything else. I built it into my experimental setup so that it will do the processing for me, and then the data is ready for me to look at. And now I can go and play my movie and see what's going on. But again, we have the raw data, so if you want to do anything else with that, or you want to tweak some settings later, you can do that still. But for those of you that have everything sort of dialed in, this is really wonderful because you just plug everything in and it's ready for you and saved in a folder for you to put in that presentation or whatever you need when you're done. One more thing, because I alluded to this, and I also put a link in the bottom of the description. I think spectral unmixing is a really untapped, wonderful way to build this into your imaging experiments. Again, because if you don't cut off in these really narrow bands when you're doing multiplexing, you allow all the light through, but you save individual spectral fingerprints. This is a really powerful way to really get the most out of your multiplex experiments. So I'll just show you, again, another case example of how you could use this. It's really, there's so many ways you can build these things together. It's really endless. So again, select direct processing in your experiment setup, and here we'll customize this for this example where we're using a confocal setup. So for example, you could put in LSM plus processing, and that's just to help, again, push the resolution in this example. And then you add a function. We can add a linear unmixing. And so we're going to reference, it's going to prompt us to reference which folder we have saved those reference spectra in. You do need your reference spectra for this. But once you do that initial legwork, if you were doing this over and over again, it's really powerful, especially when you are looking at these multiplex samples with small puncta, and you don't want to get rid of, you don't want to lose any light. You want to be able to drop that laser down and separate all your channels as easily as possible. It's a really, really powerful workflow, but it can be done, again, in all these modalities and more. And so a little bit of how that actually is set up on the back end, because that's the very basic. If everything has been set up on your instrument, you already know that you have it on your instrument and you're ready to go. You just select that direct processing and set up whatever you would normally set up in the processing tab. But it will start processing for you once each time point is done acquiring, or each position is done acquiring. How you actually set it up on the back end, I'm adding some of these to the portal. Give me 1 sec so I can pause this. So our portal, which I always highlight at the end as well, is a resource for you as our Zeiss customers where you can have all this digital training content. If you are more of you like to teach yourself and spend time going through videos, this should be added soon if it hasn't been added already. But you basically just have this checklist of, if you want to use this, this is useful for you to basically maximize efficiency on your instrument and get to your results more quickly. I just highlight some of the prerequisites if you don't know if you have it on your instrument or not. You need to be in ZEN Blue 3.3 or higher. If you want to be able to stack that stuff together, that's, I believe, ZEN 3.7 or higher. So we basically keep improving it with each iteration of ZEN, and now we're in 3.12 soon. So you would want to check that. And then, of course, typically if you do have this as part of your package, we set it up at the beginning, so you don't typically have to worry about all of this networking and Windows permissions, but occasionally software updates on the Windows side are known to mess up some things, so it's just useful to know this is how the basic setup goes. But in ZEN, once all of that stuff is done, this is what we would normally check, right? And this is for a setup where you have an offline workstation and your microscope PC, and they're connected with a direct Ethernet line, right? They're networked together. All you would want to do if you do need to troubleshoot or add anything from the beginning looks like this. We would go into the processing PC workstation, and you can always go to tools and options, and that's where the direct processing info lives. I would recommend don't mess with it unless you know that you are having an issue, but this is how you would go in and check that stuff. You have your IP address here, so we always use the same two whenever we're setting this up in the standard setup, and you would hit start receiving. That start receiving button that I just clicked is really what you would normally do once everything is set up. You only open on the processing PC and hit start receiving. Now you're communicating with your acquisition PC, right? They have a direct line to each other. Typically, that is all you have to do. If you're having, again, troubleshooting, that's where you want to go into the tools and options and look. Same thing on your acquisition PC, you can go to tools options, and this is where now in the newer versions 3.7 and above, you can actually select your microscope PC as both your processing and your acquisition if you need to. But here's where you just want to make sure it knows I'm the acquisition PC and this is the port that I'm on, and so that's how it knows that you have a two-computer setup. From there, we basically would just go in, and just like I've been showing you in all the examples, you enable direct processing in your experiments tab by just hitting that checkbox, and then you can go in and start to build out what you're doing. In this case, I'm actually on a sim system, just jumping around the lab because we have all the fun toys. And again, this is where you can change any settings you need to in terms of where you're saving your data to, the raw data, and then of course what processing steps you need to do. The really nice thing is that it is smart software and it intuits, right, we're on the sim system, so it thinks, well, you're taking a sim image, you probably need to do sim processing first. It's smart software, and so that's really great. From there, again, you can start to add functionality to it if you need to do an extended depth of focus or something like that. And so, let me back up. So if you notice in the beginning, it said process on other PC, but nothing had been added yet. It can't see that connection. So this is where, again, I like to highlight this just because occasionally Windows updates messes up some of the backend stuff we initially set up. So if you do ever have to troubleshoot, you just go and edit that connection and type in those IP addresses that are always our default addresses. You could type it in manually, add that host name, and then once you've typed in the known IP address and port 8000, you would just hit add. And then once we've hit add, we'll also find that PC, and then you can just hit connect. And now you've got the green link. Right now it can see that other computer and talk to it. It sees that the software is open and you're ready to go. So typically if we have already gone over the training for this with you on your instrument, that should all be set up. You really just have to select direct processing, but it's always nice to know how to troubleshoot in case something gets funny on the back end after a Windows update. So again, direct processing is not to be overlooked in my opinion, right? It's something that you might not know that you even already have on your instrument if you're new to using it, and it's really, really powerful to get you to your results more quickly, right? Just think about how quickly everything scales if you're used to working in 96 well plates or you're imaging multiple positions on slides. Everything that once you finish those, right, you can stitch it or max intensity project it or whatever you need to do. So from the most basic to the most advanced applications, direct processing can really be your best friend in terms of cutting down the amount of time that you have to spend. You just tell the computer to do everything for you, and then it's ready to port into whatever analysis software you might need. And so with that, I'm keeping an eye on the chat. So if anybody does have questions, please feel free to ask there. But again, we're part of your digital engagement team here at the Zeiss Microscopy Customer Center. Just because we can't physically be right beside you, we are here as your resource. So always reach out to us. We are always offering rolling workshops. So if you need more advanced training, we do both virtual and in person. I have an upcoming Skill Builder series on confocal from basic to advanced. So if you want to join that or check out what other offerings we have, please go to our ZMCC webpage and check that out. The Zeiss portal, again, if you have a Zeiss instrument, you have access to that. If you were having trouble getting access to that, please email us and we will help get you in touch with the right folks because it is full of resources in the Zeiss Academy there, including things like how to troubleshoot a direct processing setup on your offline workstation. And then, of course, upcoming live streams are here. I believe we might be taking a break next week, but we are here every other week at the very least. And with that, I'll take a minute to make sure we don't have any questions coming in. But I really hope that was helpful for those of you who are working in ZEN Blue, and maybe you didn't know that that was a feature that you could enable in your experiments to get you to your results more quickly. So if there are no questions, thanks so much for paying attention today. I've linked some of the other microminutes I referred to in the description for this one. So the lattice light sheet, just because I talk about that type of processing, the spectral unmixing, the spectral imaging workflow, as well as SIM. So just some of the more advanced microscopy techniques in case you are interested in learning more about those. with that, have a great day.